Okay, so let's keep going on. So 13.3 is facts about the F distribution. So here's some facts about it. The curve is not symmetric, but it's skewed to the right. There are different curves for each set of degrees of freedom. The F statistics is greater than or equal to 0. And as the degrees of freedom for the numerator and for the denominator get larger, the curve approximates the normal distribution. Other uses for the F distribution include comparing two variances and two-way analysis of variance. Two-way analysis is beyond the scope of this chapter, and we won't even study it. But let me show you. Here's the example of these graphs show that the degrees of freedom for the numerator and for the denominator get larger. The curve approximates the normal. And as you see here in A, it's not very normal. You can still see it's very skewed. But the one in B is starting to take that normal distribution as it gets higher, as the numbers get higher. Okay, so let's do an example. So again, let's talk about the hypothesis one more time. The null and the alternative hypothesis is, for the null, you might see it as mean 1 equals mean 2 equals mean 3 equals mean 4 equals mean 5. Your alternative could be that not all the means are equal. There are other ways to do that, but the book is pretty specific about what it wants. So basically what you're looking for in the null hypothesis is that they all equal. The alternative just means that not all the means are equal. Okay, so let's do this, solving for a one-way ANOVA example. So if you go in the book and you go on page 704, you're going to see some data for soil covering types for tomatoes. So what I did is I went ahead and I put it here on the screen because I'm going to walk you through this problem. So the question asks the means of tomato yields under the 5 mulching conditions are represented by mean 1, mean 2, mean 3, mean 4, mean 5. We will conduct a hypothesis test to determine if all the means are the same or at least one is different. Use a significance level of 5%. Test the null hypothesis that there are no differences in mean yields among the 5 groups against the the alternative hypothesis that at least one mean is different. Okay, so let me get out of this PowerPoint. Okay, so what I'm going to do now is I'm going to go ahead and let's do the first thing. Let's talk about the means, okay? The hypotheses. Okay, so for my first hypothesis, what I think I'm going to do, come on, get back in there. Okay, so the null is, I'm going to say all the means are the same. I could also put, I'm going to put or here in big letters. Or, let me go here. I'm going to go get my symbols. Mean. You know what? I'm going to cheat a little bit. I'm going back to the PowerPoint and I'm going to grab this one. Okay? I'm going to grab these because this is basically for ANOVA the only kind of hypotheses you're going to have. So you can use these again and again if it'll work for me. Okay, here we go. Okay. Or the null is that. The alternative is this. Or the way they do it in the book is kind of tricky. It's the mean of I doesn't equal the mean. Oh, it didn't do that. Let me grab the symbol. Doesn't equal the mean of J some, which it really, I'll be honest with you, I don't like this one. I'm just showing you because the book does it, and I'm not crazy about this because you know what? I'm more for the first one. I'm more for this one, mean 1 equals 2, 3, 4, 5, and then my alternative being not all the means are equal. Okay, so those are my hypotheses. All right, the next question the book wants to know is, go ahead and run a one-way ANOVA. Run ANOVA. Okay, so what I'm going to do is I'm going to pop out of my PowerPoint and I'm going to go to my calculator right here, okay? So I'm on the website, that's all I'm doing. So number of treatment groups. Remember, that's the number of categories. And I had 5 categories. The max number in any group for this was 3. you're like, Miss Pace, where are you getting that? If I go back to my table, so I had 5 categories: bare, ground cover, plastic, straw, compost. And then with each category, I had 3 data points. For bare, it's 26.25, 29.97, 49.15. So that's where that is coming from. Okay, so I put 5 here, 3 here, and I hit continue. All right, so this is ground cover. Okay, so my first one I'm going to put is bare, and I'm going to put those values in. So I'm going to put 26.25. And the next one is 2997. As you can see, I've done this before. 4915. Okay, and then the next one is ground cover. So for that one, it's going to be 5348. The next one is 5682. The next one is 5482. Again, if you're confused, I'm on page 704 of the book towards the bottom. So the next one is plastic. I'm just going to keep entering my data. 6583. Let me keep going down. And this one is 8560. This one is 3830. This one is straw, which is 7285. Oh, it's picking back up. 6897. 9230. As again, you can see that I did this before. Compost. This one is 6277. This one is 7818. And this one is 8677. Okay. So I wanted to display the graph. So once I've got all my stuff in, I hit compute. So if you look down here, remember we talked about in the video for the PowerPoints about the box plots? As you can see here, bare is a lot lower than the other ones. So there's something going on here. They're not all pretty in a line. So that would make you think that the means are not the same. But the one thing that you're going to pick up from here is this table. I'm going to try to see if it'll put it back in the PowerPoint so we can talk about it. So let's see. I'm going to go here. Let me go to a new slide. I'll put it here and see if it'll do it. Oh, it did. Okay. It did okay, but let's put it in there. Oops. Let me see if I can make it bigger. Oops, I've just made it a mess. Okay. So, all right, let me go back to this and look at it. Okay. So, I'm looking at my sources. I've got my whole table. So, for degrees of freedom for treatments is 4. Degrees of freedom error is 10. I've got my SST, SSE, MST, MSE, my F value, and my P value, okay? So those are important. All right, I put them there. They don't look very good. So just be careful when you do that they might not look that good. I'm going to go ahead and just take it off because it looks really bad. Go ahead and get rid of that slide. Okay. All right, so I ran my ANOVA, and then the next step it wants me to do is it wants me to find my distribution for the F-test. For F-test. Okay, so for this one, what I need to do is I need to find my degrees of freedom for my numerator and degrees of freedom for my denominator. Well, it's really easy because the test already does it for you. So if I go back to the website, this 4 is for my numerator and this 10 is for my denominator. So I'm going to put this is equals 4 and this equals 10. So this makes my distribution for the F-test of F where 4, 10. And those should be smaller. I'm just not going to worry about them today. So that's my distribution. Okay, so the next thing it wants to know is I'm going to do a new slide. What's the p-value? Okay, so let me go look for my p-value again. Again, it was on there. So my p-value is 0.0248. So 0.0248. So that's my p-value. So that was easy. So my p-value equals that. Another way they write it in the book is p-value equals p where f is greater than 4.481. The reason they're doing that is, remember I said it was a right skewed test. So this is, f is always going to be greater than that. Where's that 4.481 coming from? All that is that f value sitting right there. So that's all we're saying. If the book wants you to write it that way, that's another way to do that. Okay, so next part, make a decision. Okay, so what am I going to do? I'm going to look at P and alpha. Let me go up here and grab the little symbol so you know what I'm talking about. Where is my symbol? Get my Greek letters. I can find them. Okay, I'm just going to write it out so we don't waste time. Alpha. Remember, that's the little fish sign. Okay. So what was my P? My P was 0.0248, and my alpha was 0.05. Okay, so since this is less than this, I will reject the null. Oops. Why did I reject the null? Because my P is less than my level of significance. All right, so what can we say? Conclusion. All right, so let's go back for just a second and take our time. Okay, so this means this right here, I'll put it in blue or red, is not correct. Not correct, okay? So it means this one down here is correct. So I need to write it in a sentence to show that it's correct. So my conclusion is at the 5% level of significance, comma, there is strong evidence that the differences in the means, the mean yields for this, because we're talking about yields, oops, for the mulching conditions are unlikely due to chance alone. Okay, we may conclude that at least some of the mulches lead to different mean yields. Okay, what do we do there? We just said that, oops, I spelled that wrong. Sorry about that, guys. So basically what I did is I put that alternative into a friendly everyday English sentence. So I said at the 0.05 level of significance, there's strong evidence there's difference in the mean yields for the mulching conditions are unlikely due by chance alone. That means something's going on. So they can conclude that at least some of the mulches lead to different mean yields. That's all we're doing. That's exactly what we just did. And if you saw, I really didn't do anything by hand. I let the computer do it. If you have questions, just let me know on that, okay?